Surface profile in horizontal slope channel. In horizontal slope, you know that S0 equal to 0. Hence, the dynamic equation for GVF, that is dy by dx, equal to S0 minus SF by 1 minus q square t by GA cube get modified to dy by dx equal to minus SF by 1 minus q square t by GA cube. Now you know that for analysis it's always easy to have formulae which have y, yn and yc terms. So the below mentioned forms of Manning's or Chessy's equation can be used for analysis. Now in the case of horizontal slope channel, yn equal to infinity. So you don't have zone 1 existing. The only zones existing will be zone 2 and zone 3. Hence the curves there H2 and H3. Now let's see what happens in zone 2. Zone 2, you know that y lies in between yn and yc. So the limiting or the boundary conditions that can be adopted are y tending to infinity on the upstream side. That is, y actually tends to yn, but since yn is infinity, you can take the condition y tending to infinity on the upstream side, and on the downstream side y tending to yc. Now you know that always in zone 2 dy by dx is negative. Hence here dy by dx is negative. Now let's see what are the values of dy by dx when you apply these limiting condition in the dynamic equation. When y is given the value infinity, then dy by dx equal to minus sf. And when y is given the value yc, dy by dx equal to minus infinity, which indicates that H2 curve tends to approach the horizontal line tangentially on the upstream side, and it is going to meet the CDL, that is the critical depth line, normally on the downstream side. Now in zone 3, y is less than both yn and yc. So the limiting values are y tending to yc on the upstream side and y tending to 0 on the downstream side. Now again dy by dx is always positive in zone 3. Now on applying these limiting condition, when y is given the value yc, dy by dx tends to minus infinity, and when y is given the value 0, dy by dx tends to infinity. And you know that when you get a value equal to infinity, it is going to meet the nearest line normally. Here too, your H3 curve meets the critical depth line and channel bottom line normally. Now these are the H2 and H3 profiles in the case of the horizontal slope curve. That is, H2 is almost tangential to the horizontal line on the upstream side, and it is meeting the CDL normally on the downstream side. For the H3 profile, CDL is met normally on the upstream side, and it is being met normally on the downstream, that is on the channel bottom. Now let's see the surface profile in the case of adverse slope channel. A slope is said to be adverse slope when S0 is less than 0 or when the S0 value is negative. And in the case of adverse slope, yn is imaginary. Since yn is imaginary, you don't have zone 1 existing in the case of adverse slope. Only zones existing are zone 2 and zone 3, and hence the curves A2 and A3. Now let's see what happens in zone 2. Zone 2 again, y lies in between yn and yc. Now the case of adverse slope is very much similar to your horizontal slope. So here too the limiting values are y tending to infinity on the upstream side and y tending to yc on the downstream side. Once again, zone 2 is always, the dy by dx value is always negative. When y tends to infinity, then you get dy by dx value tending to S0, and when y tends to yc, then dy by dx value tends to minus infinity, which means that your A2 curve is going to be horizontal on the upstream side, and it is going to meet the CDL line, that is the critical depth line, normally on the downstream side. Now for zone 3, y is less than both yn and yc. Therefore, the limiting conditions taken up are y tending to yc on the upstream side and y tending to 0 on the downstream side. Once again, dy by dx is always positive in zone 3. And when these limiting values are given in the dynamic equation, you get y tending to yc, then the dy by dx as minus infinity, and when y is given the value 0, dy by dx you get it as infinity. As always, when you get the infinite value, then you're going to get some line meeting normally, then the A3 curve is going to meet the critical depth line and channel bottom normally. So these are the A2 and A3 profiles for the adverse slope channel. A2 is going to be almost horizontal on the upstream side, and it is going to be normal to CDL on the downstream side. A3 curve is going to be CDL on the upstream side, and it is going to meet the channel bottom normally on the downstream side.